In this video, we're going to simplify a ratio. And what do I mean by a ratio? Well, a ratio is the relative size of different things. So let's write that down. A ratio, which you spell R-A-T-I-O, is the relative size, and I'll explain what I mean by that in a second, of different things. So for example, if I said that one thing was twice as big than the other, then I'm talking about a ratio there because I'm talking about the relative size of two things. I'm saying how many times bigger or how many times smaller something is compared to another. Now let's look at these red and blue counters here. What is the relative size of the number of red counters to the number of blue counters? Well, you might be able to see that we have twice as many red counters as we do blue counters. And the way we could write that ratio, so if we wanted the ratio of red to blue counters, well, we could say for each two red counters we have, we've got one blue. Look, for each two red, we've got one blue. For each two red, one blue. And therefore, the ratio of red to blue, we would write as 2 to 1. So this colon here in the middle allows us to write a ratio. And that's basically saying for each two red counters we have one blue counter. But let's say we were to group these counters like this instead. Can you see that for each 4 red counters I have 2 blue counters? Look, for each 4 red, I have 2 blue. So I could also write the ratio as 4 to 2, because for each 4 red, I have 2 blue like that. And basically with ratios, we can multiply both these numbers here by whatever we like, as long as it's the same number. So in this particular case, I multiplied this by 2, and I multiplied this by 2 as well. But we can multiply by other numbers as well. I could multiply this 2 by 3, and this 1 by the same number, 3, and then the 2 times 3 would be 6, and the 1 times 3 would be 3. And that means that for each 6 red counters I would have 3 blue counters. And each of these values in the ratio are known as parts. So this is saying that for 6 parts red, we have 3 parts blue. For 4 parts red, we have 2 parts blue. For 2 parts red, we have 1 part blue. And we often see the word parts when we're mixing liquids, for example. So you might have seen instructions when you're making squash. Squash is something where you put like the concentrate in a glass and then you mix it with water. And it might say something like mix 1 part squash to 4 parts water. Now, it doesn't matter what 1 part is. 1 part could be a whole litre, or it could be like a gallon. It doesn't really matter. But it means that the amount of water has to be 4 times as much as the amount of squash. So we could write the ratio of squash to water is 1 to 4. That means for each 1 part we have of squash, we have 4 parts of water. And notice these numbers have to be the same order as the words in the sentence. So if it's squash to water, that's squash and that's water there. So if we had 1 litre of squash, we'd have 4 litres of water. If we had 1 gallon of squash, we'd have 4 litres of water in order to mix to make this drink that we have. Now, we just want to simplify a ratio for the moment. So we have 10 parts on the left and 15 parts on the right. It doesn't matter what this represents. It might be that for each 10 red counters we have 15 blue counters. But remember, we can simplify this ratio by either multiplying both numbers or dividing both numbers by the same number. Now, what could we divide both 10 and 15 by if it's the same number? We've just got to find factors that are common to 10 and 15. Now, 10 and 15 are both in the 5 times table, so we could therefore divide both of them by 5. And if we do that, the 10 divided by 5 is 2, and the 15 divided by 5 is 3. And that is actually the final answer. It's 2 to 3, the ratio. And we can't simplify that any further because there's nothing we can divide both those numbers by to make it smaller without getting decimals. And in ratios, we like to have whole numbers in the ratio.